Hi everyone, and welcome back to the CAD/CAM course YouTube channel. You're watching the FreeCAD Intermediate tutorial series. This series is designed to help you transition from beginner-friendly models to real-world functional designs. In this series, we'll focus on slightly more complex models that challenge your understanding and strengthen your core FreeCAD skills, including sketching, constraints, fillets, pockets, multi-body design. By the end of this series, you'll not only be confident in modeling advanced shapes, but also capable of troubleshooting and optimizing your workflow. In today's tutorial, we'll model this Rotary Indicator Knob, a practical and printable part that involves multiple sketching techniques, feature refinements, and parametric design principles. As always, we'll break the model down into simple steps and build it piece by piece. And to make things easier, I've prepared a step-by-step PDF guide. You'll find the link in the description if you'd like to follow along. Before we get started, I encourage you to pause the video here and try modeling this part on your own using everything you've learned so far. And if you get stuck, no worries, just resume the video and follow along with me step by step. All right, let's begin with step one. Step one is to create this circular base. In FreeCAD, switch to the Part Design Workbench. Click on Create New Sketch. When prompted to select a sketch plane, choose the bottom plane, also known as the XY plane. Now, select the Circle tool, place the center at the origin, and draw a rough circle. Right-click to cancel the tool once done. Next, select the Dimension tool, click on the circle, and set the diameter to 45 millimeters. The sketch turns green, which means it's now fully constrained. Close the sketch. With the sketch selected, click on the Pad tool. In the Pad parameters, set the length to 7 millimeters and click OK. The base portion of the model is now complete. Next, let's add this handle portion above the base. In FreeCAD, click on Create New Sketch. When asked to select a plane, choose the XZ plane, which is the side plane. Now, select the External Geometry tool and click on this top edge of the base. This brings it into the current sketch as a reference. Then, choose the Create Arc by Center tool. Set the origin as the center. Select the end point of the reference line as the second point, and drag the arc across to form the curved shape. Click near the other end point of the reference line as the third point. Right-click to cancel the arc tool. Next, grab the line tool and close the arc by drawing a straight line at the bottom between 2 points of the arc. To fully constrain the sketch, select the line and click the horizontal constraint button. Once the sketch turns green, it's fully constrained. Close the sketch. Now, let's extrude this profile. Select the sketch and click on the Pad tool. In the Pad parameters, check the box for symmetric to plane and set the pad length to 23 millimeters. Click OK. The handle portion is now added. Now in this step, we're going to trim the extra portion of the handle that's extending beyond the circular base. First, rotate the model to bring the bottom face of the handle extrusion into full view. Click on this flat protruding face and select the Create New Sketch tool. We'll now draw the cutting profile that will help us trim the excess. To make sketching easier, click on the View Section tool. Now select the Circle tool. Click on the origin to place the center of the first circle and drag outward to draw a rough circle. Then draw a second circle, again using the origin as the center. Make this one larger so it completely surrounds the previous circle. Right-click to exit the Circle tool. Now grab the Dimension tool, click on the inner circle, and set the diameter to 45 millimeters, which matches the base. Next, click on the outer circle and set the diameter to 56 millimeters. This will ensure it fully encompasses the extended portion of the handle. The sketch should now turn green, indicating that it is fully constrained. Close the sketch. Now press the 0 key on your keyboard to reorient the model into isometric view. Next, click on the pocket tool. In the pocket parameters, if the pocket cuts in the opposite direction, simply check the reverse box to flip the direction, set the depth to 20 millimeters, which will be enough to cut through the full height of the extension. Once everything is set, click OK. And with that, we've successfully trimmed the extra portion outside the base. Now, let's shape the handle portion as shown in the reference drawing. The handle gradually tapers from 23 millimeters at its widest point down to just 7 millimeters. To achieve this, we'll sketch a profile that defines this taper and remove the excess using a pocket operation. In FreeCAD, start by selecting this upper face of the base and click on Create New Sketch. Next, click on the View Section tool to slice through the model and reveal a clean cross-section of the geometry. Now, activate the External Geometry tool and click on these two segments of the circular base. We'll use them as references in this sketch. Grab the Polyline tool. Begin by drawing a horizontal line that starts from outside of the circular edge and ends on circle edge. As you draw, a small red hyphen will appear, confirming it's horizontal, and a dot on the arc will show when it intersects the circle. Without exiting the Polyline tool, press the M key repeatedly to toggle drawing modes until you see a tangent arc preview. Drag the arc to the opposite side, ending it at the far point of the reference line, then right-click to cancel the tool. Now we'll constrain the sketch, grab the Dimension tool, and set the vertical distance from the horizontal line to the main axis as 3.5 millimeters. Since the total taper is 7 millimeters, this value gives us symmetry on both sides. You may notice that the sketch turns green, but it still shows 1 degree of freedom. This is because the horizontal segment's length is undefined. Even though this line won't be part of the final cut, we still need to define it for the sketch to be fully constrained. So, click on the line and set its length to 7 millimeters. Press Enter. Now the sketch is fully constrained. Since we no longer need this line as part of the cut profile, right-click on it and choose Toggle Construction Geometry. This turns it into a construction line, so it won't affect the pocket operation. At this point, we have a partial profile, but it's an open sketch. Pocket operations require a closed sketch. To complete it, grab the Circle tool, click on the origin, and draw a large circle that will close off the shape. Then, use the Dimension tool to set the circle's diameter to 45 millimeters, matching the base. Now, grab the Trim Edge tool and click on any unwanted arc segments to clean up the profile. You may see some temporary warnings, just ignore them for now. Right-click to exit the Trim tool. Once everything looks good, close the sketch. Now, rotate the view to get a better perspective of the handle. Click on the sketch, then activate the Pocket tool. If the cut is moving in the wrong direction, simply check the reversed box. Set the pocket length to 17 millimeters, or use Through All to ensure the cut removes the entire unwanted portion. Click OK. The handle is now starting to take its final shape. Now that we've completed the pocket on one side, we need to duplicate the same cut on the opposite side to maintain symmetry. But instead of sketching and pocketing again manually, we'll use the Mirror tool to copy the pocket operation. First, reorient the model so that you can clearly see the entire body. Now, in the model tree, locate and select the pocket feature that we just created. With it selected, click on the Mirror tool in the toolbar. In the mirror parameters, set the mirror plane to the base XZ plane. This will reflect the feature across the central vertical plane of the model. Click OK to apply. And that's it. The handle is now fully shaped with symmetrical cutouts on both sides. Now, based on the drawing, the next step is to round off the sharp edges using fillets. We'll apply 3 different fillet radii, 1.75 millimeters, 2 millimeters, and 5 millimeters. Back in FreeCAD, start by selecting the top edge of the handle, then click on the Fillet tool in the toolbar. In the fillet parameters, set the radius to 2 millimeters and click OK. Next, select this base edge, apply the tool again, and this time set the radius to 1.75 millimeters. Now for the corner edge of the handle, where the handle meets the base, select it, apply the Fillet tool, and set the radius to 5 millimeters. Now, rotate the model to the opposite side and repeat the same sequence. 2 millimeter fillet for the top edge, 1.75 millimeters for the base edge, and 5 millimeter for the corner. With all the fillets applied, the model now has a smooth, finished appearance and is shaping up beautifully. Now we need to prepare the base of the knob to ensure it fits correctly onto the control shaft. This involves creating 2 features, a large circular hole at the center, and a tapered square cutout for the actual knob insert. Let's begin with the circular recess. Rotate the model until the bottom face of the base is visible. Select this bottom face as the sketch plane and click on Create New Sketch. Once the sketch is active, use Fit All to center the view. Now in the Sketcher Workbench, grab the Circle tool and place the circle by clicking on the origin point. Drag out a rough shape. It doesn't need to be exact just yet. Then select the Dimension tool, click on the circle, and set the diameter to 42 millimeters. The sketch should now be fully constrained and turn green. Go ahead and close the sketch. Next, activate the Pocket tool to remove the material. In the pocket parameters, set the length to 4 millimeters. Click OK. You should now see a clean circular hole cut into the bottom face of the model. Let's move on to the knob insert feature. This time, select the flat inside surface of the circular pocket we just created. Click Create New Sketch again to start sketching on this interface. In the Sketcher, click the drop-down next to the Rectangle tool and choose the Centered Rectangle option from the menu. Click on the origin to place the center of the rectangle and drag out a rough square. With the Dimension tool, set both the length and width of the rectangle to 6 millimeters. When the sketch turns green, close it. Now click on the Pocket tool again. In the Pocket parameters, set the length to 5 millimeters. And then apply a taper angle of 2 degrees. This slight taper ensures a tight friction fit when the knob is mounted on a square shaft. Click OK to finish. With that, the main body of the rotary indicator knob is complete. Now, let's move on to building the indicator strip. To create the indicator strip, we'll add it as a separate body. This way, we can 3D print the indicator using a different color or material for better visibility. So let's go ahead and add a new body. Click on the Create Body icon in the toolbar. You'll see a new body named Body 001 added to the model tree. To stay organized, it's a good practice to rename both bodies. Right-click on the first body, the one we just finished modeling, and choose Rename. Rename it to Main Body. Next, right-click on the new body and rename it to Indicator. If you look closely at the model tree, you'll notice that the indicator body is now active, which is indicated by the green highlight. You can also right-click and confirm that active body is checked. Before we start modeling the strip, let's update the appearance of both bodies to clearly distinguish them. First, select the main body, go to the View tab in the bottom, and click on Shape Appearance. Click the color box, and choose a color that fits your design. I'll go with a deep red for the main body. Now, select the indicator body, go to the same shape appearance menu, and choose a contrasting color. Something like white or bright yellow works well here. With the indicator body active and the colors updated, we're now ready to start modeling the indicator strip. Now let's create the indicator strip geometry using the Part Design Workbench. Start by clicking Create New Sketch and choose the XZ plane as your sketch plane. To define the path for the indicator strip, grab the Line tool and draw 2 perpendicular lines along the origin, one horizontal and one vertical. Next, grab the Circle tool and place the center of the circle slightly to the right of the origin on the horizontal axis. Drag out the circle and right-click to cancel the tool. Now let's constrain the sketch. Use the Dimension tool to set the distance from the circle center to the origin as 1 millimeter. Then add a diameter constraint of 47 millimeters to the circle. We only need a portion of this circle to act as our path. So grab the Trim tool and remove the unnecessary segments of the circle. At this point, the sketch may still show as under-constrained because the vertical and horizontal lines are not yet fully defined. Select the endpoints of each of these lines and apply the coincident constraint to anchor them and reduce their length. Once that's done, select both lines, right-click, and choose Toggle Construction Geometry. This ensures they won't interfere with the next operation. The path is now fully constrained. Go ahead and close the sketch. Now, with the path ready, let's create the profile for the indicator strip. Create another new sketch, this time on the bottom plane, the XY plane. Fit the view to the screen and rotate to face the bottom of the model. Now, grab the centered rectangle tool, click near the path axis, and drag out the rectangle that will serve as the base of the indicator. Next, use the Dimension tool to constrain the sketch. Set the distance from the bottom edge of the rectangle to the center as 21.5 millimeters. Set the width of the rectangle to 1.5 millimeters and the height to 3 millimeters. Now let's add the arrow-shaped tip. Grab the Polyline tool and draw a small triangle on top of the rectangle. Use the Dimension tool to set the distance from the triangle tip to the center as 26 millimeters. Next, add a fillet to the inside corner of the triangle using the Fillet tool and set the fillet radius to 0.5 millimeters. Now trim the center line between the rectangle and triangle using the Trim Edge tool. The sketch may become under-constrained after trimming. To fix this, use the symmetry constraint between the two ends of the base to restore balance. Once the sketch turns fully constrained, close the sketch. Now both the path and profile are ready. To create the 3D body, select the profile sketch and click on the Additive Pipe tool. In the pipe parameters, click to select the path sketch we created earlier. Click OK, and the indicator strip will be created along the arc. As a finishing touch, select this edge of the strip and apply a small fillet if needed. Now, change the color of the indicator to something bright. You can use white, yellow, or any color that contrasts well with the main body. And that's it. Your rotary indicator knob is now complete. You can now export the model as an STL file and send it to your 3D printer. And that brings us to the end of this tutorial. If you found this tutorial helpful, please consider liking the video, subscribing to the channel, and turning on the notification bell so you don't miss upcoming lessons. If you'd like to support my work and help me continue making high-quality FreeCAD tutorials, consider buying me a coffee on Ko-fi. Your support, no matter how small, goes a long way in helping me dedicate more time to creating detailed, beginner-friendly content for this community. You'll find the Ko-fi link in the description below, or use the Super Thanks feature right below this video. Thank you for your support. It truly means a lot. Until next time, keep learning, keep designing, and I'll see you in the next video. Together, we make FreeCAD stronger.